Our task is to learn about statistics software. There are many powerful programs available for you to do introductory statistics, such as SPSS, R, Stata, or SAS. But they all tend to have at least one of two problems for beginning statistics students. Either they are very expensive, or they are very difficult to learn, or both. If you plan on doing research, then it is well worth your time to learn one of the more complex and more powerful programs like SAS or R. But you, as a student, may or may not have one of those statistics programs on your computer. However, many people have a copy of the ubiquitous Office suite from Microsoft. I am going to use Microsoft Excel to show you the basics of data handling. And I will show you how to use the formulas and functions to simplify your calculations. The techniques I'm going to show you will work regardless of which version of the Excel software you are using, whether Mac or PC. They will also work with open source Office suites like LibreOffice or Apache OpenOffice. However, remember that your screen may look slightly different from mine. So with that, let's get started with some basic terminology. Before using Excel, it is useful to understand the terminology that we will be using in this class. Open your copy of Excel on your computer desktop and follow along with these terms. The Excel spreadsheet document is called a workbook. Each workbook can consist of several worksheets. The worksheets lay on top of each other like a flip pad of paper. In some versions of Excel, by default, a workbook will contain 3 worksheets, only one of which you need for a statistics problem. If your version of Excel gives you only one worksheet, click the bottom plus button to add 2 more so that you have 3 total. Tabs along the bottom of your worksheet tell you which sheet of the worksheet is active. For this exercise, we are using worksheet number 1. Every worksheet is made up of blocks called cells. The cell is the place in which you will type your formulas, insert data, or display other information. You can insert both numbers and letters within a cell. Numbers in cells are called values. Text in cells are called labels. Although it is not necessary for our calculations, you can change the color, size, and border of each cell. A cell is identified by its unique column and row heading. Columns run vertically, like the columns of a Greek temple, and are referred to using letters. Rows run horizontally and are referred to using numbers. The numbers and letters are called row headings or column headings. Any cell can be referenced by entering the column letter followed by the row number of the cell. So for instance, on this worksheet, cell B5 is selected. Notice that both column B and row 5 are a darker gray, and that the cell itself is highlighted. Cells next to one another are called a range of cells. When referencing a range of cells, reference the first cell, followed by the last cell, separated by a colon. For example, this column of 3 cells would be referenced as A2 colon A4. This row of 3 cells would be A2 colon C2. If you're referencing A2 colon C4, you're referencing a block of cells. When you enter numbers into a range of cells and then perform calculations on them, you can use a formula. A formula is an equation that you create that tells Excel what to do with data in your worksheet. You can create formulas to perform mathematical operations, such as addition or multiplication. The formula that I typed here will multiply cell A2 by cell A2, effectively squaring the value in that cell. You can choose a cell in which to type the formula, where the result will appear, typically next to the data that are being added or multiplied. Excel also includes functions, which are predefined formulas that do much more complex analysis, such as calculating standard deviation or the mean. Formulas can be typed directly in cells, but are often easier to edit in the formula bar, located near the top of your worksheet. If the formula bar is not visible, show it by using the menu and choosing View, View Formula Bar. Formulas and functions follow the same general format. Both always begin with an equal sign, and with functions, the range of cells goes in parentheses. The sum formula that I typed here will add up the values in cell A2 through A4. You can also use constants in your formula. You could divide every cell in a column by the same number. I do this when I divide the points earned by each student in a class by the total number of points available in the class to calculate each student's grade. Excel has a variety of built-in functions that can make doing statistics easier. You can use Excel to do statistical analysis and hypothesis testing, such as correlation or t-tests. But you should be aware of the limitations of Excel, especially if you need your answers to be accurate out beyond 15 decimal points. Remember, the suite is called Microsoft Office, not Microsoft Classroom or Microsoft Statistics Laboratory. Excel was created for doing office work in a business. The good news, however, is that we are still wading in the shallow end of the statistical pool, and we do not yet require such an exquisite degree of precision. Excel and its open source alternatives provide an excellent tool that will simplify your statistical computations. Plus, there's some very nice third-party add-ins that give Excel the power to do statistical analysis. Of course, Excel is not the only spreadsheet in town. I've already mentioned some excellent open source alternatives, such as LibreOffice or Apache OpenOffice. Those offer all of the functionality that we will need for this course. And if you're looking for an alternative to Excel, watch my video about alternative statistics software.